Hi, my name is Tanja Vos, and in this video I will explain to you Testar, a tool for test automation at the user interface level. So let's start to see what is Testar, where does it come from? So Testar results from a research and development project, which was a European project called FITTEST on future internet testing. And this project ran from 2010 to 2013 in the context of the 7th Framework Program of the European Commission. And Testar, a tool for automated testing at the user interface level, is one of the results of that project. So why is Testar useful? Why is automated testing at the user interface level useful? So the user interface is where all the functionality of an application comes together. So testing at the user interface actually encapsulates both integration testing and system testing. Then the second reason is that the user interface is what the users of your application see, and it's what they use. So any fault that arises at the user interface level is important because that's what your clients find. So testing at the user interface level tests your application from the user perspective. Then another reason why it's useful is that most applications have user interfaces. Computers, tablets, smartphones, and so all applications have a user interface where what the user uses to operate with your application. Then another good thing for Testar is that it doesn't need source code of your applications, and it can detect a lot of information needed for testing at the user interface level without needing source code. Obviously, if we could access the source code, it would be good, because then we would have even more information to direct and evaluate our tests. So to get clear, we now get the point of what is Testar, so let's look what Testar is not. So Testar is not a capture replay tool. So capture replay tools, what they do, they capture user interaction at the user interface level and record a script. And then these scripts can be automatically replayed during regression testing. Then if the user interface changes at development time, for example, or runtime, then what happens with capture replay tools is that the automated regression tests break. And this actually causes a huge maintenance problem, and testers find themselves actually repairing broken scripts instead of doing some real testing. So Testar is not capture replay. The other thing that Testar is not, it's not visual testing. Visual testing tools that do testing at the user interface level are based on image recognition. These tools are easy to understand and actually do not really require a lot of programming skills to use them. And also they solve a little bit of the maintenance problems, but they introduce additional problems, which are related to the performance of image processing and false positive and false negatives that are associated with the ambiguity of image locators. So Testar is also not visual testing. What Testar also does not do, it does not generate scripts. Testar just generates tests. So what is Testar again? Testar derives test sequences from a tree model. And this tree model is being automatically inferred from the user interface. So the tree, what it does, it reflects all the widgets that are on the user interface that a user can see in a determined state of the user interface. So on the slide here we see a very simple example. Here we see an example user interface with 4 menus, some text field and some sliding bars, and a button, but this button is disabled. So a specific widget tree of this interface we see here. So we have the window, here we see the button, we see the text field, we see the menu that has 4 menus we can choose from, and we see this slider here. So this would be a very simple example of a widget tree. And this widget tree, this model we use for testing in Testar, is being automatically inferred. And we do this through the accessibility API of the operating system on which the application runs. So this tree model is inferred each time the state of the user interface changes. And so when the user interface changes, the model changes, and so do the tests. And this means that we can significantly reduce the effort of maintaining the tests that are being generated with Testar. Let's look a little bit closer on how it works. Here we see a diagram that actually displays all the steps of Testar. So we start up the system under test, the SUT, and in the specific state where it is when we start it up, we scan the GUI. We scan the graphical user interface and obtain this widget tree that we have seen on the previous slide. Then from this widget tree, we derive a set of user actions. We derive the set of actions that a user can execute in that specific state. And when we have this set, we just select one and we execute it. Yeah? And that's basically how the testing goes. Let's look at a more detailed example of a widget tree again. So here we see a system under test, and this is the active widget tree. We see there's lots of things on the user interface that are present, but we cannot click on all of them. So actually the only user actions that we can click on in this state of the user interface are the green ones. Here, for example, we see 1, 2, 3, 4, 5 green things that we can click on, and these actually go inside with the 5 menus that we have here on top. So we can click one of them. So imagine we select one of them, we click on that, and then the state of the user interface changes and goes on to the next state, which we see here, where this menu is open. So this means our user interface has changed and the widget tree is adapted. We can see this here below. We have opened this menu item here, and all these things now become available to the user also to click on if he or she wants. We see that some are gray because they are disabled, and the green ones are the ones that are enabled that we can select. So going back to how it works, we were here, we have a set of user actions that are green that the user can do at the specific state of the user interface, and we select one. Then we execute the actions and we can go on, scan again the state, derive a set of user actions, select one, execute, and so on. So this is all automatically. The interesting part when we consider testing is here. So every time we have executed an action and the state of the user interface has changed, what we need to do is execute an oracle. And the oracle, what it should do is see whether our test found some error or not. And this is actually, later on we will see what type of oracles Testar already has per default, and any other oracle the user needs to program. And we see this input here on top where we need the domain experts, mainly the testers, that program them. So if one of these oracles has found some error, then we stop the execution of the system under test, and if we want to do more tests, we start it up again and go on testing. So for what types of software does Testar work? Actually, it works for all kinds of software. We see here on the slide a little bit very simplified architecture of Testar. Testar uses the accessibility API of an operating system to detect the widget trees. So what we can do, we can write a plugin that translates the operating system specific accessibility API to the abstraction layer of Testar. And then within Testar, here in this box, all the test specific components like the test generator and the oracles are then based on the abstract representation in the form of a widget tree. So by writing a plugin, we can make sure that Testar works for most kinds of software that respect the accessibility API. And since browsers are just an application running on an operating system, once we have the plugins, we can also test web applications that run in these different browsers. So let's see how it works. Here is the interface of Testar, and we see the different things we can do. We can spy an application, we can generate tests, we can replay tests, and we can view what has happened. So let's do a basic setup. We just say, okay, here I'm going to put the path to the system under test. Where is the system under test? And then we set some things we don't want, like for example, we filter some undesired actions that we don't want to execute when testing. Think, for example, of closing the system under test or minimizing the system under test. We don't want this all the time while we're testing. So we just filter those actions. and we filter some undesired processes, like for example opening Acrobat Reader when displaying a manual or something. We don't want that too, so we filter that, and then we go. So here in this video we see an example of how this works. So the user interface is being scanned. All the green dots on the screen mean active actions that Testar can choose from, which it does. And the one it selects is the green dot that is over there. It selects it, it clicks on it, and the state changes. And this goes on and on until we have found an error or until we have reached some stopping criteria. So as I indicated, the important thing are the oracles. An oracle is that thing that determines whether a test has revealed an error or not. And an oracle in Testar is a function that takes the state of the user interface is in, and it gives a verdict about that state, fail or not fail. So let's look at some oracles that we already have in Testar. Oracles that can be 100% automated are oracles that can find crashes or can find whether an application is hanging or something. And let's look at the code and how we can program that. It's very easy. It's done in Java for now. Here we have an oracle, for example, in Java that can detect a crash. And what you see, the oracle is called Oracle Crash. It receives the state the user interface is in at that specific moment, and it just sees whether in that state the application is still running or not. If not, then we have the verdict of the oracle that says the system has crashed. Something similar for the hang of an application, the oracle responsiveness, it gets the state as the input, and we see if it's not responding, then we raise a verdict saying the system is not responding. So these oracles are if per default in Testar. So what we can do is automate a test that can detect crashes and hangs. But we can do a little bit more, which is also easy. There are oracles that make it easy to specify widgets that have suspicious titles. Suspicious titles, you can think, for example, of error, problem, exception, null pointer exception. Titles or words that we don't want our user to see in our application. So we can add these in Testar by simply specifying the words that we consider suspicious in a regular expression. And actually, if we look at the Testar interface, there's a tab for that, which is called Oracle, and here we can put the regular expression that indicates the titles that we find suspicious. And then Testar, when it runs, in each state, it will check whether the title of a widget contains one of these suspicious words. Under the hood of Testar, looking at these suspicious titles, we have another oracle. And the oracle has the same structures as the other one, which is oracle suspicious titles. It takes as an argument the state the user interface is in at that specific moment. It gets the regular expression that we have set to be suspicious titles, and then what it does is for each widget in this specific state, what we do, we compare if the title matches the regular expression with the suspicious titles, and if it does, we raise a verdict and say, okay, we have found a suspicious title in this and this widget. So any other oracle you want, you can add by programming it. And this just means you make a Java method that gives a verdict on the specific state the user interface is in. Let's look at another quick example that we can add easily. Think, for example, of the Web Accessibility Initiative guidelines. These guidelines say that every image in an interface of a web application needs to have an alternative description. So we can easily add an oracle for that. We can see here on the slide. Oracle that gives a verdict of this images guidelines of the WAI initiative. So what we simply do, for each widget in the specific state, we look if it's an image and if its title is empty. And if it is, we are violating this WAI guideline, and we raise a verdict saying that not all images have an alternative description. So that's how easy it is to add a new oracle. So if we want to deploy Testar in our company and test a specific system under test, there's basically three things we need to do. First we plan, like we always do, no? First we plan how to use Testar, and we implement it in a test environment. And we look if Testar can recognize all the widgets and all the user interface elements that we have on our screen. And we start filtering the ones that we don't want to use when we are testing. Then, during the planning, what we also do is we anticipate and identify potential fault patterns that we want to find when testing. So, detect crashes is for free, as I indicated before. Detecting suspicious outputs or messages is very easy to do. We just put a regular expression. But anything else you want to test, we need to plan, anticipate, and see how we're going to define this in an oracle. So once we've done that, we implement it. So we implement the oracles that indicate how we can detect the errors that we want to find during testing the system under test. And finally, when we have everything set up and implemented, we test and find errors in the SAT. So, how was Testar used? We've actually been using it a lot after the European project has ended. We have tested the whole Microsoft Office suite. We have tested even a testing tool that is called Testar, which is an Eclipse-based desktop application for making combinatorial test trees, and we have used Testar to test that test tool. We have tested some ERP desktop applications, and we have already tested a lot of web applications that we get from companies that are interested in trying out Testar. So, if you are interested in trying out Testar, on this slide you find our contact details, there's an email, our webpage, and obviously you can like it on Facebook if you want, or you can call us or WhatsApp us.